Well, thank you very much, Rosa. Hello, everybody. I'm Dr. Peter Stutz. I am the chairman of the Vagus Nerve Society. And it is really with great excitement and great pleasure that I get to introduce our next session, which is about vagus nerve stimulation as a tool to improve focus, energy, readiness in today's warfighters. We've been doing a number of different webinars over the past few years on various topics, covering things such as anxiety and treatment of migraines and post-traumatic stress disorder. And it was so intriguing for me to see the work that the Air Force Research Laboratory has been doing on vagus nerve stimulation. And I am absolutely thrilled with our next two presenters to talk about vagus nerve stimulation for performance enhancement. It's kind of a new and novel topic for us that I think is going to be really interesting and frankly open up a whole new area. At today's session, we're going to have Andy McKinley, who I've known now for a number of years, who has been leading some really great research that he's going to tell you about, and Eric Liebler, who I've worked with, it's been about 10 or 15 years now on topics around the vagus nerve society. Eric is absolutely one of the most knowledgeable people out there around the vagus nerve with its interaction with brain function. It was a co-founder of the Vagus Nerve Society with me, and I've been around this whole topic for quite some time and has been intimately involved in the development of some of the technology that Andy's going to talk about. So without any further ado, I'm going to turn it over to my good friend Eric Liebler to introduce our session.
Thanks. It's a pleasure to be here, and thank everyone who's in the audience for taking an hour, really it'd be more like 45 minutes of your day to join us. This whole world of vagal nerve stimulation, I think, has been expanding by leaps and bounds, and that's really only accelerating because people have always been curious about the vagus, but there weren't really the tools to examine it easily accessible to researchers and to the real world. I was involved with some of the early technology testing, the clinical testing, over the past decade plus, and was introduced to Dr. McKinley and his team at AFRL probably about 6-7 years ago, where they reached out and said they were interested in vagal nerve stimulation for cognitive and human performance. Our history, our approach had always been focused in the medical field, and it really wasn't something that had been top of mind for us. But when Dr. McKinley and his team dug in and explained what they were doing and why, and the potential intersection and value of the vagus nerve as a access point, as a conduit to support human performance, it made a lot of sense. We're going to turn it over to Dr. McKinley for the rest of the story. He is the leader of the neuromodulation and applied cognitive neuroscience team at AFRL. AFRL is the leading research organization, perhaps within the entire military, but certainly within the Air Force. They help develop, test, design the technologies and tools that our warfighters use every day to secure and support our nation. And what Andy's group does is really take care of the core at the center of that function, the warfighter themselves. Because you cannot manage or control any technology without having that ability to excel yourself. So with that, I will turn it over to Andy. He's just published a little bit in this area of, I think at last count, 120 publications. It's been great fun working with him, and I continue to be what the military calls a point of contact, which means you can ask any questions of us at the end of the session that you like. Dr. McKinley, thanks for joining us. I'll turn it over to you.
Well, thank you very much for the nice introduction. So I'm Andy McKinley. I've been with the Air Force for about 23 years now, and I've been doing a lot of neuromodulation work over the years, and it's been a really interesting area for enhancement of otherwise healthy individuals. My background's in biomedical engineering, although for basically my entire career, I've been focused on neuroscience. And anyways, I'm going to be talking about TAC-STIM, which is a non-invasive device that can stimulate the cervical branch of the vagus nerve. I did want to say that what I'm presenting today are my views and my opinions, not necessarily those of the Air Force. And I don't have any conflicts of interest. I don't have any stake in Electrocore or any products at all. I just work for the government. That's it. So at any rate, I just wanted to get that out of the way. So bottom line up front, we've been investigating different types of neuromodulation over many years since, I guess, around 2007. We recently started doing work with the vagus nerve back in around 2017. And what it has led to is a research area where we've been using non-invasive stimulation of the cervical vagus to accelerate training, sustain attention over long periods of time, reduce the effects of fatigue on cognitive function, and boost mood. So the whole point here is to get a military specific device out in the hands of our operators where it can have a meaningful impact on their ability to conduct their missions safely and effectively. Next slide. So it's probably not a big surprise, but the military suffers from fatigue, just like a lot of other folks, but it's a pretty big incidence rate here in the military. You know, it's a high stress career field, specifically for some of our special operations groups as well. They're not getting adequate rest. There's high levels of attrition related to burnout. There's mission sets that require folks to perform for up to 40 hours or more sometimes. We also have complex mission sets, so training can be lengthy and complicated, which also makes it expensive. So, there's an interest in reducing the amount of time it takes somebody to learn these military skills. Right now, there's a lot of caffeine use, a lot of energy drinks. Even in the training communities, you go to an operational base and you may see folks walking around with 2 energy drinks in their hands. The average is three or more per day. And so, with caffeine, we know that with high doses and chronic use, the effects typically start to decrease. It's less effective when people are extremely fatigued. And, it has some negative side effects, high blood pressure, increased heart rate, irritability, insomnia. And so, our team has been looking at these non-invasive stimulation approaches to provide a more targeted performance without having lots of side effects. So we've been looking at learning rate. We've been looking at sustained performance over long periods, sleep deprivation periods of 36 hours. And we've been also quantifying the effects on mood. Next slide. So this research really started back in 2017, early 18, with a DARPA program called Targeted Neuroplasticity for Training. So we had been doing some neuroimaging research showing that other forms of stimulation, like transcranial direct current stimulation, was actually producing effects in deep brain structures in the brainstem. And that got us thinking that perhaps we are actually activating peripheral nerves. So at the same time, the DARPA effort started up, and we were investigating different branches of cranial nerves, such as the vagus and the trigeminal nerve. Um, what worked the best was the cervical branch of the vagus nerve. So we were teamed up with Wright State University and electroCore on this program to evaluate that. They had a product called GammaCore, which is a clinical device used to treat cluster headaches, and we were repurposing it for our healthy folks. And so what we were doing was bringing Air Force participants in and training them how to analyze synthetic aperture radar imagery. So all these folks were naive. They didn't know what they were really looking at. We were teaching them how to find small surface air missile launcher targets in the scene. And we were also changing things in the scene and asking them to identify what had changed. So these are things that an image analyst would need to know to be able to do their job correctly. And what we found, if you look there at the top right, is that when we stimulated every day for over the course of a week, the learning rate increased significantly for the folks getting stimulation. We also did a follow-up test 1 day, 30 days, and 90 days after the training sessions that were paired with stimulation. And we found that the retention rate was also elevated in the people that got stimulation. So that effect size actually grew to about 35% when you got out to 90 days post stimulation, which was really exciting. I think this was the first time that we had shown, or that anyone had shown, accelerated learning in a healthy, normal population using a non-invasive cervical vagus nerve stimulation. We also expected that there may be off-target effects with the idea that stimulating the vagus would also downstream have impacts on brain areas like the locus coeruleus, and that's involved with learning, attention, arousal, wakefulness. So we looked at sustained attention. We looked at arousal with a simple reaction time task. And the attention task here was a simple vigilance task called the Mackworth clock test. It's a task where you're watching a dot move around in a circle, much like the second hand moving on a clock. And every now and then it would skip a position, and the person would have to respond when they saw it skip a position. So it goes on for like 30 minutes. It's pretty hard to maintain attention on that task for that period of time. But what we saw was that there was no change in vigilance over the course of the task and over the course of the week with the people that got stimulated. The folks that didn't, they got worse over the course of the week. Same with the arousal metric. And that got us thinking that, because we're seeing these off-target effects that are consistent with what we would expect if we were seeing changes in locus coeruleus, perhaps we would also see changes in wakefulness. So next slide. Oh, I'm sorry. So just a little more detail on the learning task. So what you're seeing here is an example of the type of imagery that they were examining. And so first they would have to identify where the target is by clicking on the piece of image where they thought the target was. And what we see there is better accuracy, but we didn't really see any change in the amount of time that it took them to find the target. And then we would change something in the scene. So either a target would move, rotate, change identity or disappear completely. And we also saw improvements there in terms of the accuracy, but not the response time. Next slide. So as I mentioned, we decided, let's look at the effects on fatigue using a sleep deprivation protocol. So we kept people up for 36 hours, 20 people in each group. And that what they were doing was a set of cognitive tasks every few hours. And one of those tasks was called the multi-attribute task battery. And I'll show on the next slide what that looked like. But essentially, they're doing 4 different tasks at the same time that roughly mimic the types of tasks that a pilot would have to do. But what you're seeing here in the bottom left is that the performance on that task was sustained over the course of the vigil. And the blue line there is the folks that got the sham or placebo stimulation. And you can see how that splits out as people are getting more and more fatigued over the course of the night. We also did the simple reaction time task, which is called the psychomotor vigilance task. And that one we also saw less decline in the people that got stimulated. The other interesting thing was that they had significantly fewer errors. So when we look at their false alarm rate, for example, there was no change from their their healthy alert baseline, whereas the sham group got worse over time. And then the other thing was people felt less fatigued. So at any rate, there seems to be a robust effect on mood as well, which we've seen across pretty much all of our studies. And if you're interested in reading more about the study, we published it in Nature Communications Biology. Next slide. So this is the small picture there is the task itself. So there's a tracking task where they're controlling a cursor with a joystick. There's a visual monitoring task or system monitoring task where they're essentially looking at simulated instruments and looking for them to go out of range. There's also a communications task where they're listening for their call sign and making changes to their communication frequencies. And then there's a resource management task, which you see at the bottom of that picture, where they're managing fuel levels in 2 tanks by turning on and turning off pumps. And so what you're seeing here is splitting out the overall performance into the 4 different tasks. And what you'll notice is that 2 of the tasks seem to be driving all the results, which is the system monitoring and communication task. And interestingly enough, these are the ones that would require the most attention and also the most discrimination. So people are essentially looking for subtle changes in the instruments on the visual side, and they're also listening for their call sign on the communication side and having to discriminate that against the noise. And so in the DARPA program as well, a lot of the effects were on helping people discriminate either language or these small differences in the visual imagery that they were looking at. So at any rate, just saying that consistent with the earlier findings. Next slide. Following those studies, we got some funding from the Office of the Undersecretary of Defense to essentially develop a product that was military ready. And so this also came with it some field testing. So we partnered up with our Air Force Special Operations Command to evaluate the technology on their image analyst trainees. In parallel, we were conducting a tech sprint to develop a military-specific product that adhered to the end user requirements. Next slide. So the results of that are going to be shown here on the next few slides. So we did see an effect on the learning rate. So people were getting to proficiency earlier in their training. We also saw a lot of effects on mood and positive effects on mood. So on the right of this slide, the top chart there is the day one before they got stimulation, and they were getting stimulated daily over the course of a week. And so these were the mood factors that we were measuring, and blue means that sham was higher than stim. Red means stim was higher, so higher is better, higher than the sham. And so what you see there is everything's basically in the middle. There's more that are, slightly to the left, slightly higher with the sham group. But by the time you get to the last day after stimulation, you can see 100% of those things have shifted to the right. And so anyways, it was just interesting to see that essentially all the aspects of mood got better for the stimulated folks over the course of the week. And this was a very, very difficult, high tempo training week. Next slide. So when we get into the weeds on specific aspects of mood, they felt less distressed with the stimulation, and the effects were present both immediately after stimulation, and then also we did another questionnaire at the end of the day. So on the far right is the end of the day results, and you can see that the effect builds over time, just like it did in our earlier studies with the accelerated learning program. But you can see those effects ramp up here as well with the operational folks. So we do believe that chronic stimulation is better. We did do some optimization in the phase 1 of the DARPA program, and we started out doing just every other day of stimulation. Yet every day we got a much bigger effect size. Next slide. People were showing higher levels of being happier. They were also more confident, so they felt more able to do the training. Next slide. And importantly, they were seeing or reporting higher levels of energy. So again, this is an effect that we've seen energized and less fatigued. Overall mood was improved as well. And so, these are pretty consistent findings and repeatable findings over our study populations, but it was really good to see it in the operational environment where things are more messy and less well controlled. So it's a pretty strong effect. Next slide. We also had the opportunity to do a study with the Defense Language Institute. So these were Air Force participants only, but essentially we were comparing nerve targets. So comparing the cervical branch and the auricular branch. I don't have the auricular branch data shown on the slide. The story there is we didn't see any significant differences in the groups with the auricular branch, but we did with the cervical branch using the electrocore device. So again, we saw significant improvements in learning rate, which is the plot on the left. So the stimulated folks were learning the Arabic language at a faster rate. And the task here was they were learning English and Arabic word pairs. So every day they were given a list of 100 words, and they got to practice those for about an hour. And what we found was that they were getting those more correct at a faster rate over the course of the week. And then they also were to see how much they learned during the training, and also saw a significant effect there. Next slide. So one of the really interesting things was the mood again, right? So what you're seeing here, the sessions 1 through 5 are basically Monday through Friday. So session 1 is Monday, session 5 is Friday. And they're getting the STEM paired with their training on Tuesday, Wednesday, Thursday, session 2, 3, and 4. So what I have bracketed there are the stimulation trials. And what you're starting to see there is that the plots are starting to cross. And so what that's indicating is that the people that were getting stimulated are actually starting to feel more energized after their training than when they started. And you can see for the sham group, they get more fatigued, which you would expect. I don't know that I have ever sat through an hour of any kind of training, let alone something very difficult like learning Arabic words that are rarely used, which is what we were using in this task. And then, at the end of that training, feeling like, yeah, I'm ready to go. I'm more energized. So at any rate, it was just a really cool finding, really interesting to me. So next slide. Let's see, I think we've lost the slides.
I'm sure they'll pull them right back up, Andy. There we go.
Okay. Okay. So we then took this to a different training task. So here we had naive subjects, so they were not pilots, but they were learning how to do an approach to runway. And so they had to fly a very specific glide slope on final approach. And what we found here is that when we provided stimulation just prior to their training, so on the plot, the vertical lines are where they receive stimulation. And we would pause. So we did stimulation, then we did 6 trials, so 6 landings, then paused, gave them another dose of stimulation. This was around maybe 15 minutes break. So you can see, after we put people back into the sim, it took them a minute to get reacquainted with the simulation. So you see that performance decline there. But then the stimulated group actually that slope gets better in the second set of 6 trials. And so the effect size actually grew in that second set of trials. But essentially what you're seeing here is the error. So root mean square error around that glide slope. So lower is better, lower is less error. And so the red is the stimulated group and the blue is the sham. So at any rate, this was really exciting to us because it shows now that we get this robust effect on learning rate across very different tasks. And so, it started us thinking that, perhaps this is a general effect on learning, and it's not task specific. So next slide. So back to the product development. So we had a tech sprint that was my team from AFRL, Eric's team from Electrocore, and then also our operational users from AFSOC, Air Force Special Operations Command. So basically, we gathered all the requirements and desirements from the end users and work through, designed. The end result of that was a device called the TaxDim, which you're seeing on the right. So the left is the original Gamma Core device that we used in our early research, and then that's the final product there. Next slide. So I've talked about the effects on readiness, right? So accelerating training and getting folks ready for their mission earlier. So that's one application. We also showed some data on mission support, so sustaining performance over long periods of time and reducing the effects of fatigue. Increases in multitasking capability, improvements in response time and vigilance. But we also think that there's applications for post-mission. So, I showed the robust effects on mood improvements. We also know from the literature that stimulation of the vagus is a good stress reducer. And so post-mission, folks need to be able to, military operators need to be able to return to their baseline as quickly as possible so that they can decompress and get ready for the next stressful mission. And so we think that this technology, this nerve stimulation, could have beneficial effects in terms of getting people into, back to their baselines more quickly. Next slide. So in terms of the final product here, the device is a lot more sturdy and robust. It's not going to break if you drop it. It's a hardened case. It's easier to use. There's fewer intensity settings. We've basically made it dummy proof, right? So there's really just one button to turn it on and then one button to move it to the intensity level for the individual. And then you just hold it on your neck and it does everything else on its own. So the paradigm is 2 minutes of stim, a short break, and then two more minutes of stim. So this will automatically pause and then restart the stimulation, so they don't have to hit any more buttons. So anyways, the military operators seem very happy with this, and this is what the military will buy in the future for at least the TaxDim device, or for the Electrocore device. Next slide. So because the effects are pretty significant and they are robust, we've been getting a lot of interest from operational users who have started purchasing devices and are actually starting to use them in their operational communities. So our first use case was with the Air Force Special Operations Command. So you can see 3 different units there that have purchased the device and are using them now. And we've been getting really good feedback from them on the performance improvements that they've been seeing. And we've got some anecdotal evidence that, people that were, heavily addicted to caffeine use are now doing away with caffeine, and, they're good with just using vagal nerve stimulation. USASOC, that's our Army Special Operations Command. There's 4 different units there that have been purchasing devices. Air Combat Command is currently evaluating the devices along with the U.S. Army. They're looking at it for Black Hawk pilots. Navy Special Warfare is using them in some of their internal evaluations. The 10th Mountain, so this is Big Army, has made purchases as well, and they've deployed those. And then we're also working with our Air Mobility Command. So they are interested in both the training and the fatigue reduction applications, because they are likely going to be needing to operate for long periods of time, so up to 40-hour missions to move material around. And so we're in the process right now of getting set up to do the ground-based simulation training ground-based simulator testing in the C-17 airframe. And then the follow-on to that will be doing some flight testing. But at any rate, there's a high level of interest there. One thing that's not shown on here is our global strike folks are also interested. So these are B-52 pilots that are having to do aerial refueling. So they're very interested in testing that for that application. Next slide. So, there's always questions about safety especially when you're doing testing with otherwise healthy people. And so, our experience here in the lab, we've run probably close to 1,000 people through various research protocols here, as well as out in the field. And, we've never had any issues. The top 3 side effects are listed down there: headache, muscle twitching, and metallic taste. So the muscle twitching and the metallic taste, that's only during the stimulation, and it stops as soon as you pull it away. The headache, just wanted to caveat that with the fact that we're doing a lot of fatigue research, and so headache comes part and parcel with staying up all night as well. And we were restricting caffeine use, right? So people that were potentially used to having a coffee in the morning, they may be getting headaches as a result of not having their caffeine as well. Next slide. So also, I just wanted to give a comparison. Some of our pilots are prescribed long duration missions, which is modafinil. And modafinil has 43 side effects above the 1% rate. TVNS devices have 8. Next slide. And then when you really get down to it, the top side effects for modafinil are headache at 34% and nausea at 11%. The TVNS devices are much, much lower in terms of incidence of both of those, but also the incidence for all the other side effects that are shared with modafinil are much, much lower in terms of incidence rates. Next slide. So that's the presentation, and happy to take questions.
All right. Thanks a lot, Dr. McKinley. So we've been collecting the questions in the Q&A session, so we appreciate that. We'll get to as many of them as we can. You also have emails for myself and Dr. Stats up in front of you if you want to go offline with some of the questions or want to follow up after that. We had over 200 people registered for this, which makes it one of the most popular ones. I'm sure not everyone showed up, but as we said, this is being recorded and will be available at the Vagus Nerve Society website. So I'm going to start out at the 360 or 360,000 foot level, Andy, with a couple broad questions, and then we've got some specific questions as well. So as you've been using it in all these different settings, as you think about it going forward, what are some of the application spaces, either within the military or outside of the military, where you think some of your learnings could be applied?
Yeah, great question. So, a lot of this is dual use, right? So, fatigue mitigation, accelerated learning, that's also of interest to society at large. A lot of different professions have chronic issues with fatigue, whether it be medical professions or, long haul truckers or, shift workers, people working night shifts suffer chronic fatigue. So, I think there's a lot of dual use applications for this technology. It's not just military. It's just, I work for the military, so that's our emphasis at this point. In terms of other applications that we're looking at, the next thing for us is, on the recovery side. So, as I mentioned earlier, we're interested in stress reduction or stressful mission.
Thanks very much. It's also, I've had the pleasure of working with some of our operators and the kind of stress reduction, agitation, et cetera, something that's been being explored within the Army side as well. We had a specific question about fatigue, and I think this might be some confusion about when it was deployed in one of the studies. This comes from Michael Gigo, and I'll ask forgiveness if I mispronounce anyone's name. His question is, he thinks the effects on fatigue are interesting. What about the onset of effect? Do the benefits of stimulation, were they delayed with significant improvements coming 9 to 15 hours later? Does this mean you have to use the stimulation in advance rather than immediately after fatigue sets in? What are your thoughts on that, Dr. McKinley?
Yeah, so yes, I think that it basically works as a countermeasure to prevent the fatigue onset. So you would want to use it before you're already fatigued. We do have some data that I didn't show here where we tried applying it in the middle of the night after people were already super fatigued, and we did not see as big of an effect. So our recommendation right now is that, you'd want to apply it, before you start your mission.
Thanks. And, keeping an eye on the time, we're coming up on 45 minutes. We know some people will be disappearing. We'll take a few more questions.
Potentially do another dose around 12 hours in.
Thanks, Andy. Sorry, there was a bit of a lag. We're going to keep taking a few more questions. Remember, you can follow up after. Another question came in here from Claire Marie Rangon. Thanks for the question. What's the, where was the, she had a couple. Have you looked at long-term effects? The data you showed has been typically out to around 5 days. How long do you expect these effects to last? Anything you can tell us in that area?
Yeah, another great question. So, in terms of the acute effects, we've only done 1 week duration studies. We do follow-ups, like I mentioned, 30 days, 90 days after. But we haven't done chronic stimulation for more than a week, at least on our healthy participants. I will say that on the medical side, there are folks that are using it, chronically for, months or years for treatment of headaches. So, Eric, you could probably answer that question a little better than I could. But yeah, at least for us, we haven't done any long-term chronic stimulation studies.
Sure. I mean, from a broader vagal nerve stimulation perspective, the headache studies were formally lasting for more than 6 months and had people who have been using it for multiple years. So in that setting, you have long-term benefits. It's approved for prevention of diseases and not just acute treatment. But it's important to note we have not done those type of long-duration formal studies in a performance setting. I am aware of Army units using them within an operator for 3 months to kind of work on a number of specific training or mission-related activities, but that's in an anecdotal setting. There's been several questions on here that all relate to what are the differences between some of the different forms of non-invasive vagal nerve stimulation. I'll handle that one because, Dr. McKinley and stuff explained what he's been working through. And I would equate it to walking into that car dealership. You've got some Bentleys, you've got some BMWs, and you've got some Minis. All of them have got an engine, and all of them have got a signal. But beyond that, there are some very specific differences that are designed for that audience. And in TAC-STIM in particular, it has to do things that some of the other units don't have to do. It has to operate in an aviation environment and not just in a commercial jet. It has to be used in facilities where certain things are not allowed. So they all are designed fit for purpose. And you can look for more information from the company or on those websites. Here's an interesting one, Dr. McKinley. Is this better for physical stimulation or more for learning retention?
Yeah, so that's a very good question. We haven't done much in the way of physical fatigue or physical training, but that is on the roadmap of things that we're going to be testing. So we have another group here. Their lab is called the Strong Lab, but essentially they do a lot of physical training. They've got a gym set up over here, and the people are all instrumented out with different physiological sensors, and we plan to pair the stimulation with their paradigms to see if we see any improvements in terms of their physical performance.
All right, thanks a lot. We're only gonna have time for a couple more. I'm gonna do one broad one, and Dr. Stats, I'd love you to walk in on this one as well. So the first one's gonna be a general one we can all talk about a little bit, and then I've got a final one that just is too much fun that I have to give to Dr. McKinley. So the broader one on a really sciencey side is, what's our hypothesis about stress mitigation and VNS? Why might this be mitigating stress? And let's go with Dr. McKinley first, Dr. Stats, and I'm sure they'll cover everything we need.
Yeah, so
Andy's in one of his frozen
there's
moments.
matters that are associated with basically augmentation. So that is largely driving the effects on mood and the stress reduction.
Thanks. Dr. Stats, you go back since the founding.
Yeah, no. So look, I've been looking at this for a long time, and there are not just one, not two, not three, not four, but there are multiple mechanisms by which vagus nerve stimulation modulates the stress response. First of all, it changes certain brain activity. Some hyperexcitable brain activity can be settled back down. We call it cortical spreading depressions. Second, it modulates neurotransmitters in the brain, norepinephrine, serotonin, glutamate, GABAergic pathways, all have been shown to be modulated by vagus nerve stimulation. Third, it directly activates areas of the brain that are associated with arousal. And so we can take a person who is in a hyperarousable state, very anxious, PTSD, and we can modulate that as well. So I think at this point in time, we've known that vagus nerve stimulation of some sort clearly affects numerous pathways that improve mood, improve anxiety, improve focus, all of which can lead to an improvement in a sense of anxiety, as you're asking directly.
All right, thank you both. And now for the final question. This is from an anonymous attendee. So, Dr. McKinley, how many enlisted personnel could benefit from something like this? Hundreds, thousands, tens of thousands?
Yeah, I mean, it's, yeah, probably into the thousands or tens of thousands. We're looking at things that are fairly general, a general effect on learning and memory, right? A general effect on, mood improvement, a general effect and stress reduction, wide range of military mission sets and communities.
Excellent. Well, I know that as I've been out visiting some of the bases and posts where this is being deployed, I've had the good fortune of seeing it, put to use in training and in trying to enhance accelerated learning of a mission set. So with that, I'm going to thank Dr. McKinley, our featured presenter today, for taking time out of his day there at Wright-Patt Air Force Base, for joining us. For Dr. Stats, for both founding the Vagal Nerve Society and putting on webinars like this. And of course, the team, Michelle and Rosa and everyone behind the scenes, and our audience for spending some time with us on this Wednesday afternoon. You saw our emails, so you know how to get a hold of us. This little dinosaur is where you can find the Vagal Nerve Society. And that's where this video presentation webinar will be housed for you. So with that, thank you very much, everyone, and have a terrific afternoon, evening, rest of your day.
Thanks, Eric. Thanks, Andy.
Thanks, Eric.